Teacher, I have a question on the lesson 14.
Lesson 14 ah. Unit 2 ah.
Yes.
Perfectly collision ah. Okay, which question you have problem? 14. Am I just open first ah? Just a moment, please. 14. Okay, which one you have problem? Oh,
F- First and two,
first and second.
I have I feel a bit how to say
No confident.
confused, a bit confused.
A bit confused ah. Okay. Okay, 214 ah. So this is a question taken from 2.14. 2.14. Suppose you have two objects. Okay, object A with the mass of this travel with this to the east, north, south, west, east. Okay, head-on collision. That means this A moving with 0.26, moving with 1.3, collide with B. B is not moving. So the mass is 0.17 kg. Perfectly elastic. Okay, we have to determine the final. So that means A is going to move with a new speed. B also going to move with new speed. And we need to find the final speed of both of them. So this is before and after. Okay, before collision, after collision. Okay, normally we need to use the principle of conservation of momentum. By principle of conservation momentum. Principle of conservation of momentum. M1 U1 plus M2 U2 is going to be equal to M1 V1, M2 V2. So our first equation is 0.26, 1.3. This one no speed, so put 0. So this is 0.26 V1 plus 0.15 VP, VN, VBN. Okay, so this is the first equation. VA and VB. 对，wrong. Okay, so this one, the value is going to be 0.16 times 1.3, 0.338. Second equation, let me see the work, the notes. Do they use principle of conservation of moment? Perfectly elastic. Yeah, they didn't give the equation. So you can use this one. The second one, normally we need to use something called relative speed of approach equal to relative speed of separation. Approaching. So this one not moving. Approaching, normally you have to assume object before and after. U1, U2, B1, B2. So before collision, actually U1 should be faster than U2. After collision, the momentum will pass to the second object. B2 will be faster than B1. So this one, the faster one, because this one, the A is moving, but the B is not moving. So we have to take the velocity minus velocity. So this is U1 minus U2, B2 minus B1. This is 1.3 minus 0. V2 is VB, so VB minus VA. So we'll give you the VB is equal to VA plus 1.3. So you need to substitute into here to get the value of A and B. So 0.26 VA plus 0.15 VA plus 1.3. It is now 0.338. These two plus together 0.41 VA plus 0.15, 1.3 plus 0.195 is now equal to 0.338. So the VA is going to be 0.338 minus 0.195 divided by 0.41. It's going to be 0.35 meter per second. Is it correct, the answer? Double check it. Any mistake or not? This one is plus 1.3, 1.65. Anything wrong? Let me know. Is anything wrong? Or not?
No, I'm learning. I'm seeing this.
So this is called relative speed of approach. The full name is relative speed of approach. It means is how fast the thing is going to happen, collision, how fast the collision is going to occur. Second one is the relative speed of separation. It means how fast these two after collision, the separating, moving to two directions. Okay, now finish already.
Okay.
Okay, second one. second one is about the B is not stationary, but is traveling to the west. If A is moving, B is also moving to the west, means they are actually towards one another. So everything is the same. 1.3, 0.26. The other one is 0.15. Now it's moving with 1. Okay, so we need to form the equation again. Also, the first one you have to use by principle of conservation of momentum. Mass 1, speed 1, mass 2. Speed 2, if it's to the left, is negative, so we have to put a negative sign. After that, will be still the same mass, but BA means after that, they're still going to moving to the right for A and B. So the other one is 0.15 BB. Okay, assume that they are moving in the same direction. Okay, so what is the first value? 0.26 times 1.3, 0.338 minus 0.15, 0.188. Okay, second one, you have to use relative speed of approach equal to the relative speed of separation. Approaching V1 minus V2, U1 minus U2. Equal to V2 minus V1. Okay, first object moving 1.3. Second object is negative 1.1, 1.0 because negative direction. V2, V1, no problem. Still VB minus VA. It means the VB is 2.3 plus VA. Now you need to solve these two equations. Okay, try to solve it. Okay, can you try to solve these two and give me the answer? 来，大家做一下。征信 can do the answer or not? Try to work out. VA and VB. Hmm. What is the question? Hey, can solve or not? Okay, all of you will have to solve and give me the answer.
Teacher, how to get the UB? Oh,
UB, which one UB? VB or UB?
VB.
This one.
Yeah, the final answer I didn't I forget.
You sub 2 into 1. Substitute into here 0.188, 0.26 VB, VA, 0.15 BB, take from here 2.3 BA. So we have 0.26 VA plus 0.15 times 2.3, 0.145, 0.15 VA. So this is 0.41 VA. This one can bring to one side. 0.188 minus 0.341. Okay, this one will give you a negative value. If negative means our assumption is this one after collide, A will change direction. It will go to the left. The VB 2.3 minus 0.383. Yes, so it's 1.917. Any question? No?
Oh, okay.
Okay.
You
Answer that one only two significant figure. That means the first answer is 1, second answer is 1.92. Okay.
okay?
Any more?
I think it's no more lah.
No more. No more. If no more, then we go to the 3.5. Coulomb's law. Just a moment. Okay, lesson 5. Coulomb's law. Coulomb's law is talking about charge. Charge is Q. There are two types of charge. Either it's positive or negatively charged. How to produce charge? You can produce by friction. You can also produce charge by induction. Okay. So this one basically will tell you about if you put two charges together, either attract or repel. Unlike charge attract. Like charge repel. Same charge repel, not same we attract. As well. The three low. This one. Okay, we come back here again. So two possibility, attract or repel. Okay, sometimes you can see here, let's say we put a positive charge here, negative charge here. When this one, when the first metal ball is getting closer to the second one, then you will cause a light charge as attractive force, or you put negative. Okay, if it's negative, then you push this charge to this way, push another charge to the other way, then the thing will start to spin. Okay, so actually this is related to the angular momentum. Okay, spinning effect, top, sometimes it's called top, turning effect. Okay, this force will cause something to turn. Deflection A. Okay, deflection. Okay, let's go through the test together. If you drop a tennis ball, the force of gravity is responsible to a fall. It takes about 1 second for the ball to fall from a height of 1 meter. How long do you think it would take for the ball to stop? As when it hit the ground, it would take a lot less time than the time it took to fall. What force is responsible for making the tennis ball fall? Electric force is a repulsion between the protons in the tennis racket and the proton in the ground force stop it. Such an electric force was significantly stronger than gravity. Recall the charge attract, repel in instance without making any contact with those objects. However, the exact nature of electrostatic force is complex. This is talking about history again. Okay. Ordering the distance between them, the charge meaning measuring the angle of rotation. In each case, Coulomb was able to determine the relationship between the electric force, distance, and the charge. Okay, so we need to pay attention to this formula. When you have two charge, this charge 1 and this charge 2. The force between them maybe is repulsive. The separation depending on is R. So the force that acting on these two charge is equal to K Q1 Q2 over R squared. So actually the formula is the K is 1 over 4 pi epsilon naught. So Coulomb's law tells us about this formula. This is a formula from Coulomb's law. For each charge. Okay. We take a break for a while. Okay, 5 minutes break. Yes, it's about. Come back after 5 minutes. Okay. Are you all ready? Are you all back? 回来了没有？袁斌 OK 吗？袁斌
OK。
OK 哦。OK，行。嗯。 Okay. Uh, okay. So basically, we need to compare the force 啊，就是说它们到底有多强。Okay, you're talking about Coulomb force 啊。Okay, we are comparing with the for Coulomb force is between the two charges. For weight, okay, we are comparing the magnitude of the force. Okay, actually, uh, electric force, if you compare these two values, electric force will be much larger than the weight. Okay, in here they talk about the similarity. Gravitational force is always attractive. Directional electric force depend on the type of charge. Sometimes attract, sometimes repel. Magnitude of the electric force is much larger than the magnitude of the gravitational force over the same distance. For example, you won't be able to see the uncharged pitch ball moving towards one another under the action of their mutual attraction. OK，他就说，其实，呃，gravitational force is always attractive，就是说它一直是往下掉的，you always falling towards the center of the mass. So, let's say this is the Earth. Let's say this is a mass one, mass two, mass three. When you release the mass will always be attracted to the center of the Earth. 这个是地球啊，已经会吸过去。But when you're talking about the charge, then it's a bit different. Okay, it depends on type of the charge. If you put a positive charge here, you'll be moving away. If you put a negative charge here, it'll be attractive. So it can be repulsive or attractive, depends on type of the charge. 就是说它可能是 attractive，也有可能是repulsive，就是说有两种可能性。OK，either one。OK，然后 the magnitude of the force，对，然后他讲这个 magnitude 啊，他说 electric force is much much larger than gravitational force. If the gravitational force is very large, that means when you are walking 就是我们走路的时候，我们会互相吸引的。Because when two things has mass, you'll be attracted to one another. So why we are not attracted because to one another? Because actually this force is actually very big. 这个是很弱，对啊，我们不会互相吸。Electric force is much larger compared to this，它是比较强。Okay. And then 这个的意思是说 inversely proportional because for the Coulomb's law both of them will be Gmm over R square. 这个是 Coulomb's law 的 formula. Electric force no, this is the Newton law of gravitation. This is the Newton law of gravitation. This is for G. For electric force, it's called the Coulomb's law. Coulomb's law is Q1, Q2 over 4 pi, epsilon naught R square. Just epsilon naught. Okay? Or it can be written as K Q1, Q2 R square. So as what we can see, for gravitational force is inversely proportional to R square. Electric force also R square. Okay? So this is a similarity. Both of them are non-contact force. So this is one. Let's see the question one. This one. Okay, let's see this again. Charge determine the force. F equal to Q1, Q2, 4 pi S naught, not R square. Let me see the formula. Okay, there's a K value. I think better use this one. 0.8.99 times 10 to the power 9. Okay, we don't use this. We use K, Q1, Q2, R square. 8.99 times 10 to the power 9. Q1 and Q2 is the charge. So it's 1.8 and 10 to the power 8. The other one also the same thing. So just square it. Total charge, each one of them has separated by this. Okay. Distance between them is R square, so it's 1 square. Can you find this value? Try to count. 8.99 power 9 times 1.8 power 8 square divided by 1. So the force is going to be 2.91 and to the power of 26 Newton. You get the same thing? Any question? 志愿 okay 啊？
Yeah, okay.
Second question. Okay. Second question. Small sphere charge. Exert the attractive force 0.9 on the other charge. What is the sign of the second charge? First charge is a negative charge. Coulomb, microcoulomb. Microcoulomb. The force is 0.5. Another sphere has a magnitude of charge. The other one, they didn't tell you whether it's positive or negative. You only know this is fine. But since this is attractive, that means it's unlike charge. Unlike charge means the second one has to be positive. Attractive force. So the second charge is negative, positive. Okay, because it's attractive. B, find the separation between them. We have F equal to K, Q1, Q2, R square. R square will be K, Q1, Q2, F. R is the square root of K is 8.999. Just one. 8 minus 6. Micro is minus 6. The other one is also minus 6 divided by the force. Okay, try to work out the answer. Wenjie. Wenjie, can you raise your hand? Are you there? Wenjie 有在吗？文杰
有
有啊，来你算一下，把距离算出来。
Why is Q1 positive?
Attractive force, because says that the first field is trying to attract the second field. First field is the first one itself is negative. If it's attracting the second one has to be positive to be attracted. If it's negative, then will repel.
Yeah, but then
So,
the formula is positive 8.
oh, you mean the formula? Formula we don't care,
Yeah.
because formula is we only look interested in the magnitude.
Oh, okay.
So this one you just ignore it. Otherwise, you won't get the answer one. Because square root negative value undefined. Cannot. Wenjie, Mr. Wenjie, how are you?
7.5 7.6.
No, that's all. 1.6 sure. 8.99 power 9 times 8 to the power of minus 6 times 5 to the power of minus 6 divided by 0.5, then square root of the answer. Not correct. Or any other answer? 志愿
0.85.
Yeah, 0.85. Check again our answer. 0.85. Victor. Two charge separated 5 cm. Force 24 Newton. Determine the charge on each one. If charge of one of the sphere is 4 times on another one, Q2 equal to 4Q1. Can you find? No, try not. Try it. Find the Q1 and Q2 by using this formula. KQ1, Q2 R squared. Have you got the answer? Put the F inside. 24. K 8.99 power 9. 8.99 power 9. Okay, great. Okay, 8.99 power 9. Q1 is Q. Q2 is 4Q1 over distance. This one change to meter. Let's do then square. Wow. Why am I writing back over? No battery. Just wow. Okay. Okay, this is -2, n squared. Find the Q1 square. Because here this is the Q1 square. Q1 square is 24 times 5 to the power of -2 squared divided by 8.99 power 9 divided by 4. Okay, this is going to be 1.669 and to the power of -12. Okay, so the charge of each one of them is going to be 1.29 and to the power of -6 coulomb. Okay, this is the charge for first coulomb. In the second one, okay, will be 4 times of the first one. So it's going to be times 4, 5.17. Can you get the same answer? Yes or no? Ziyuan? Okay or not?
Yeah, okay.
Yeah. The last one. Oppositely charge the force. what will be the new force if one of the charge is half? So the force is K Q1 Q2 R squared. So if charge of one of the object is half only for one, it means if Q1 prime is half of original. So if only one of them is half, then the force should also be half. It means the new force is half of the original force. Let's say this is new charge for Q1 is half of the original Q1. So you cause the force to be half. So half of the 8 is 4. Second one, what if the one of the charge is triple? Triple means 3 times original. If only one of them is 3 times, then the force will also be 3 times of original. 24. If charge on each one of them is double, this one double, means the new force will be double for 2 times. That means 2 times 2 is 4 times original. So it become 32 Newton. What if the distance is double? This one is an inverse law. If the distance is double, then the force will be 1 over 2 square. Be 1/4 of original force. So it's 1 over 4 of 8. So it become 2 Newton. Okay, are you clear with this? Okay, not this one. Inverse law, like that. If one charge double, just double for 1 time. If one charge triple, then go for triple. If the both of them double, then need to double for 2 times. So become 4 times. If the distance is double, this is the inverse law, 倒反的. If this one 2, 这边就变1 over 2 square. So 1/4 original, so it's 2. Any problem? Do you understand? Any question? Maybe? Okay or not? Anything that you want to ask or not? Ziyuan?
Yes.
Okay? Can or not?
Yeah,
Then we follow?
can.
Okay, yeah. If no problem, then we shall
We
go
still got more.
more, still got more.
Yeah, the
Oh, this
page
one.
331, 346, 346.
3 to 6, 3, 3, 1, 3 to 6.
346.
3, 4, 6. Okay. 3, 3, 1, 3, 4, 6. Okay. Okay, here. Three, four, six, right? 3, 4, 6. First one, force KQ1, Q2, R squared. K, 8.99, power 9. 5 minus 8, 1 minus 7. R is convert to meter, minus 2. Okay, let's find the answer. Chen Xin, get the answer. What is the force?
Why is the charge negative for this one?
Why is the charge negative?
Yeah, because just like you said, formula, you know the negative charge.
There's no negative charge. They didn't tell whether it's positive or negative. You won't know. We don't know.
Oh, okay.
We won't know. So this is just a magnitude of the force. Magnitude, we don't care about the sign. We don't care whether it's positive or negative. But if it's negative means it's attractive. If it's positive means it's going to be repulsive force. Okay. So by right, it should give you this answer. If you cannot get this, that means something wrong. Minus 2. You get minus 2? Minus 2. Right? Okay, minus 2. We need to do 3, 4, and 6 only. 3, 4, and 6. Okay, how about the next one? Magnitude of the force. Magnitude of force, a charge exert on the other charge located this away. Just apply the formula. Lah. K, Q1, and Q2, and R squared. 8.99 minus 9. Power 9. Located is a distance, 1.5 square. Okay, Yan Bin. Calculate the answer. How much is the force? Nhân viên chẳng kể mà anh chịu á. Okay, who else can give me the answer? Vân Chế.
One point nine two.
1.92. Okay, unit is Newton. Two equosphere experience reciprocity force. How far apart? Q1, Q2, R squared. So we are looking for how far apart. So we're looking for R. Okay. 8.99 power 9. Q1, Q2, same magnitude. No. Charge same magnitude. The 话一样的话就直接 power 2啊。So we power 2 then divide by the force. Okay. 真讯，来算一下。多少？拿到吗？哎，有人做没 ？A1，
0.51.
900万。 Okay. 3.5. Okay. Superposition. All forces, including the electrostatic forces, are vector quantity, and they are the laws of vector addition. The equation describes Coulomb's law uses only the scalar quantity without understanding the direction of the force always acting along the line joining to the center of the two charges. However, when two charges experience force more than one, the total force on this is the vector sum of the separate contribution. Commonly forces example of superposition principle, when all the charges lie in the line, the individual forces will be attracted or subtracted from one another from resultant and net force. The charges not on a straight line, but the solution require use of triangle and vector sum. Okay, so we need to do vector sum. Okay. Net force of Q3. Which one is Q3? Middle one Q3. 2 and 1. Negative, positive, negative. So Q will be attracted by Q1. So this is force number 1. There's also a force attracted. The Q2 will go and attract Q1. This one positive. So these two forces are in opposite direction. So you need to minus. Q1 is due to K Q1 Q3 R squared. Here, try to calculate it. K value Q1 2 micro minus 6 Q3 1.5 also minus 6 distance 1.5 square. Okay, check for this value first. Can you give me the answer? Hey, next week onwards, this class, I think I had to switch to Wednesday. Any problem if I change to Wednesday 8 to 9:30? Then your Saturday will be free. You can do wherever you want. Okay, not any problem. That means we have class on Monday and Wednesday.
Okay.
Yeah. How about the rest of you? 陈勋、文杰、严斌，OK 吗？陈勋 OK，文杰 OK 吗？严斌 OK 吗？严斌有在吗？严斌跑去哪里了
OK，
？OK 啊，OK 啊，Let me change。OK，放在 group 里面先。Okay, so force number one is going to be 8.99 power 9 times 2 to the power of minus 6, 1.5 to the power of minus 6 divided by 1.5 square. One 0.1 1.2 Newton. Okay, you need to find another force. So the second force is due to Q3 and Q2. Okay, so you have to put in the same value. The charge, you have to consider these two. The distance, you have to take the distance here to here. So here to here is 4 minus 1.5, so it's 2.5. Okay, so what is the answer now? Okay, the answer is different. This one. What do you get? 1.8 power minus 6. Here, do you get the same value or not? 3.988 minus 3. The difference is very big. Is it because of the charge? No. Or because of the distance? Okay. So now you have to see if they are in opposite direction, then the net force you have to subtract. Take the larger value minus the smaller value. So larger should be this one. So it's going to be 8.2, 8.12 times 10⁻³ Newton. Can you get the same answer? And this one is should be towards Q1. Yeah, no? Any problem? No? use the same charge on Q2 due to Q1 and on Q2, Q1 and Q3. Q1, 2, 3. 1, 3, and 2. Negative, positive, negative. Due to Q1, negative and negative repel. Due to Q1 is repel. Due to Q2, attract. Q3, due to Q3, attract. So need to find one by one. Due to Q1 and 2, K is 8.99. Q1, due to Q1 repel. 1 and 2, charge on 1 and the 2. 1 is this one. 2 is 1.8 times 10 to the power 1.8 minus 6. 1 and this point different by 4. So 4 squared. Okay, try to get this. Then find the one due to Q2. Q2 is Q1 and Q2. Oh, this one is Q to Q3. Q3, 3 and 2. 1.5 and 1.8. R square. Q to 3 is distance by 2.5. Okay, calculate the size of these two forces. Two 2.02. Another one is 3.88 minus 3. So the net force, larger force is Q3. So net force, you have to take Q3 minus Q1. $1.86. Okay, this one is towards charge 3. Okay, to this point, because this is larger. Okay, not can any problem. Net force. Net force on C. Three forces are arranged at the corner of the right angle triangle. What is the net force on C? Three charges. Where are the three? Triangle. Corner the right angle. Is it this one? What does it mean? Why got three forces? They got three charges. See 1 and 2 only. Where's the third one? Ziyun, where's the third one? And see or not?
I
Any
don't
third?
know.
You don't know. What incomplete one, the question? Ayo, which triangle you talking about? About charge. Arrange at the right corner. Let's say we assume it's here. Oh, maybe it's here. But we do not have the distance. This one same charge. Maybe A pushed here. This one should be negative charge. So attract. But we do not have the distance. How to find? Force. C. Net force is here. If we follow, just follow the force given, then straight away the net force is just Pythagoras theorem. Is it like that? So simple one. Third charge be here. So this is a force due to B. Right on C. One, 4, 5.4. That's all. Not enough information. You can only do this much only. Okay. Any other thing that you want to ask? I think that's all for today. This one you can continue on the Monday. Monday we continue this one. Monday, should we do more on the unit 2 啊? Unit 2 got problem or not? Unit 2可以吗? Or you want teacher to guide you more on this? How is the progress now? 边边 OK 啊？边边讲什么情况现在？
没有，lesson 14就可能有点 confuse 哦，因为它的那个算式很奇怪。
哦，就14、15就完了是吗？
啊15就完了哦，十五
可以做啊，都可以做吗？
我做了，然后14
没问题啊。
比较难，14就
这
不难，很复杂啊，比较复杂一点。
比较复杂一点啊。So Unit 2就不用了啦，就跑 Unit
哦，
3了咯。
我不懂啊，你问他们呢？
哦，看 progress 啊。Unit 1这些全部完了噻，还是这样？这不用了
你
哦。
完全部完了。
Unit 2也是 OK 的哦。这些后面这些没有讲到我一些，
这些我教了啊，
已经教了啊，不用看了啊。叫我们从 Unit 3啊，
交
拜一我们
给你，
上言
不 send 给你了。
也 send 给我啊，对。叫我们从 Unit 3继续走往下走啊。OK 啊，有问题再倒回去啦。OK 啊，拜拜。
可以了。
哎。